Ladies and gentlemen, we're going to talk about ratios in the media today. Basically, when we talk about ratios in the media, the first thing we're going to look at is television screens. And the way television screens are advertised is by the length of their diagonal. So here you see me measuring my TV, and you see that it's about 49 to 50 inches. This is actually advertised as a 50-inch screen. And I think it's just a little bit over 50 from the outside corner to the other, but the screen's actually advertised as the viewing area, so it's 49 and a half, which classifies it as a 50-inch TV. So ratios here are expressed as width to height, width being the larger measurement typically. So here we have a TV, and we have a way to measure this TV. So here's how we look at the dimensions. Here's the diagonal. From one corner to the opposite corner is the diagonal. The diagonal and the aspect ratio can help us find the width. It can also help us find the height. So we're going to try to do that right now. For a rectangular shape such as a display screen, the longer side is called the width and the shorter side is called the height. Aspect ratio of width to height. What is the approximate aspect ratio of the screen on your graphing calculator? Consider only the window and not the entire screen. So here we have the basic TI Nspire graphing calculator, and we're going to bring our trusty ruler on here, and notice here that I'm measuring in centimeters, and this is always approximate. I mean, this screen, it may have shrunk the ruler or shrunk the picture of the calculator, but we'll get a basic idea here one way or the other. So it looks like the width is 6.1 centimeters. And then we're going to try to find our height, and it looks like our height here is 4.1 centimeters. So the way that we express this is a ratio of width to height. It's 6.1 to 4.1, and we can also express this as a ratio to 1, but we must first do 6.1 divided by 4.1, and you're going to get somewhere very close to 1.49. And so this ratio is also expressed as something to 1, 1.49 to 1. I imagine your graphing calculators will be very, very similar. So now we go on and we try to find the measurements of the width of the screen and the height of the screen. And here's a few pieces of key information. The aspect ratio of older televisions is 4 to 3. We call that a full screen. And the aspect ratio of the newer widescreen televisions is 16.9. So here we're going to take an older full screen television that has a 25-inch diagonal and has an aspect ratio of 4 to 3. And we want to find the area of this screen. So what we want to do is we want to notice that this is a triangle, it's a right triangle, so we can use Pythagorean theorem. We can also use similar right triangles. So if we know the aspect ratio is 4 to 3, 4 being the longer, 3 being the shorter, and we know that the corresponding diagonal of the bigger television is 25, then we can find what's called the constant of proportionality, and then we can multiply our 4 by k and our 3 by k and get the width and height of the actual TV screen. So here let's figure out what x is for those of us who remember our Pythagorean triples and Pythagorean theorem. 3 squared plus 4 squared equals x squared. When you put this in the calculator, you're going to get 25 is equal to x squared. And then the square root of that is equal to 5. So here we have 5 and its corresponding 25 in terms of similar figures, and k is equal to this 25 divided by the smaller 25, and K actually equals 5. I know that may be a little confusing because there's so many 5's going on, but K is equal to 5. So to find the width and the height, we multiply by that K. 3 times 5 and 4 times 5, that'll give me the height is equal to 15 and the width is equal to 20, giving us our aspect ratio of 20 to 15. And then we're asked to find the area. We multiply the width times the height to get the area. So 20 times 15 is equal to 300 inches squared. So now we're going to do the very similar process with a 48-inch television screen who has an aspect ratio of 16 to 9. So this is a newer widescreen television, 16 by 9 ratio. So here's how you would set the problem up. You're trying to find the width and the height of the bigger television, the bigger triangle, but we're going to use this aspect ratio of 16 to 9. We're going to find X, and then K is equal to 48 divided by X. So again, we're going to have Pythagorean theorem. 9 squared plus 16 squared equals X squared. And when you put this in the calculator, you're going to get 337 is equal to X squared. And then X is going to be equal to the square root of 337, which is approximately 18.36. Now for the sake of our work, you can use either the square root of 337 or its approximation 18.36. Remember earlier I told you that K is going to be equal to 48 divided by X, so that's 48 divided by the square root of 337, which is approximately 2.61. Our width is going to be 16 times K, and our height is going to be 9 times K. So our width is 41.84 approximately, and our height is approximately 23.53. Remember, lastly, we're asked to find the area of that TV screen. So we have the width times the height, which is approximately, when you calculate, 984.5 inches squared. The next thing we want to be able to do is figure out what percentage of a screen is occupied by an image when the image ratio and the screen ratio do not match up. So here we're told that the screen is a 4:3 ratio and the image is a 16:9. You should be able to see that the image width and the width of the screen are equal. So that means we need to find a factor that the screen width of 4 can be multiplied by for the image width of 16. So basically 16 divided by 4, since the widths are the same, and you're going to get 4. And so then we have to multiply that 3 by 4 as well. So that means if we were to take this, the basic idea is that the screen is 16 by 12 versus an image that's 16 by 9. So if we take the two areas, 16 by 12 is 192, that's the screen area, and then the image area is 144. So what we want to do is we want to take the area of the image, 144, divided by the area of the screen, 192, and you get approximately 0.75. So that means 75% of the screen is occupied by the image. Let's try that one more time with a different picture. Notice the pillar boxes are on the left and right as opposed to the top and bottom. So here we see that the height of the image matches the height of the screen. So we need to see a factor of 3 that goes into 9. So here we have the screen is 16 by 9, and since the heights match up, we now have to take this 4 by 3 and multiply it by a factor of 3. So 4 times 3 is 12. So 4 times 3 is 12, and then 3 times 3 is 9. So the area of the screen is 144, the area of the image is 108. And so if we divide these, we get 108 divided by 144, again, is 75% of the screen is occupied by the image. You're going to have a similar question just with a different aspect ratio for the image, and so I'll show you how to do that real quick. So first you're going to do 16 divided by 1.85 and you'll get 8.65. So what that did is that told us that our screen was 16 by 9 and our image was 16 by 8.65. And so you'll see here that the only difference in these is these two measurements of the height. So we can just take 8.65 divided by 9 and we'll see that 96% of the screen is occupied by this 1.85 to 1 image. Do the same thing with the full screen. We're going to take 4 divided by 1.85 and you see that it's approximately 2.16. So that tells us that our image is 4 to 2.16. And again, all you have to do is divide the heights because that's the only difference. 2.16 divided by 3 is approximately 72%. Alright guys, a few reminders from back at the beginning. A full screen image is a 4:3 ratio, a widescreen is 16:9. To find the width and the height, you must multiply the aspect ratio by K, and to find the area, you multiply the width and the height. A full screen's constant of proportionality, or K, is 5, and a widescreen's constant of proportionality is the square root of 337, which is approximately, again, 18.36. Alright guys, that's aspect ratios in the media.